Hello guys, I'm Alukoshayo Enoch. Welcome to my math tutorial class on geometry and measure. And in today's tutorial session, I'll be working on similarity and congruency of triangles, other 2D and 3D shapes. Okay, however, we may not be able to complete this assessment task right now. I may need to take you through my board work on similarity and congruency. Now guys, let's get started with geometry and measure. Okay guys, let me quickly run through this board work so that we have a very good knowledge of geometry and congruency, so that I'll be able to complete the task accordingly. Okay, we'll be taking a look at the following content: congruent shape, similar shapes, scale factors, and using congruence and similarity. Okay guys, if shapes are identical in shape and size, then they are said to be congruent. If you look at this one now, all these shapes are identical in shape and size, and the only thing is that you just change the orientation or something like that. Okay guys, okay, so congruent shapes can be mapped onto each other using translation, rotation, and reflection. So guys, I need to make a note now. So meaning that if you can recall transformation. So any shape that undergoes the following transformation, translation, rotation, and reflection will definitely be congruent to each other. Okay, so what makes this triangle congruent to each other? If you have bound, you see that this side here, side AB, okay, has the same dimension with side PQ. Similarly, side BC here has the same dimension with side QR. And finally, side AC here has the same dimension with side PR. So guys, I need to call your attention to something. In congruency, the angles does not change, but the side can, like in case of enlargement, the size can vary, but the angle will remain the same. Okay, so then definitely angle A equals to angle P. Okay, and the same order, angle B equals to Q and C to R. Okay guys, let's quickly take a look at some tasks here. Let's try to complete the following tasks. Now, two triangles are congruent if they satisfy certain conditions. So guys, you have to note this: two triangles are congruent if they satisfy certain conditions. So what are the conditions the triangle needs to satisfy? So let's take a look at each one. So the first condition that must be satisfied is that the sides must be similar to each other, that is like corresponding to each other. We have side. Okay, so let's take a look at side. Okay, the three sides of one triangle are equal to the three sides of the other triangle. Look at this now. This is some scaling triangle, and you look at this dimension is the same thing as this dimension. This dimension here, that is the length, if you measure it, is the same thing as this, and similarly the third one. So let's take a look at side angle side. The two sides are the two sides, and the included angles in one triangle are equal to the other side, to the other two sides and the included angle. So this is the included angle. Now when we say included angle, it means that the angle is in between the two given side, and we look at this angle between the two given sides, so that this side dimension is equal to this side dimension. So the length is the same. That's what I mean by dimension. So let's take a look at AAS, that is angle side. So two angles at one side of one triangle are equal to the corresponding two angles at the side in the other. And so if you look at this now, this angle corresponds to this angle corresponds to this, and this third one here. So let's look at RHS. Okay, right angle hypotenuse side. Okay, and the hypotenuse on one side of one right angle triangle is equal to the hypotenuse on one side of the other right angle triangle, and you can see that, guys. So we don't need to waste much time. We have a lot of tasks to complete. Now, here are this we have to determine if the four given triangles are congruent. Okay, if you look at this triangle now, I have side, but this thing we need them three dimensions. See that you have side angle, so we need three parameters. But in this one we have two parameters, and this angle is unknown, so definitely we can never tell if these are actually congruent, because one information is missing. So you can't say no, because you can not say for certain that is no, and definitely it's not yes, because something is missing. We need three parameters here, so I can't really tell. Okay, and yes. Oh, what? Are these triangle congruent? Oh, I'm sorry about that. Okay, so guys, I didn't look at this one here because we need angle side. Okay, so sorry, side angle, so it's actually yes. I think I need to start all over, guys, but that's not a bad deal. So don't forget that you need two, at least three parameters, because with this thing seems to be covering this angle, so I didn't really look at this shaded one. This is angle 90. So the information is complete because you have angle side, okay, or side. So it's okay. Yes. Okay, let's go to the next question, guys. Or let me just work on more. Okay, like what I've been saying before, this one now angle is missing now because I can't see that one, so definitely this one you can't tell. Let me just be fast. Okay, let's take a look at another one. I explained that already. This one you have three side already, so yes. And you look at the corresponding side, 8.18, 0.18, 0.58, 0.577, so it's correct. And let's take a look at another one. You have everything correct because this side, so it's yes. I will not waste much time again. I will just be very fast here. Now this one you have included angle. The only problem with this one is that the included angle here is not the same. This is 62 and 55, and I said earlier that the included angle should be 55. So this is no. It's no. You can say that it's actually no because this angle is not the same. Even though the side not even, also this side is not equal to this, so it's no. So let's take a look at another one. And this one, the included angle is 68, and I have this, so this is yes. Okay, let's take a look at another one. Here, the included angle is 62, the included angle is 65, so it's no. So let's take a look at another one. This one, okay, we have two angles here, 91 and 35, 91 and 35, and 8.6 in between, so it's yes. Okay, guys, I think I need to continue now. I don't need to waste my time with this again. Including angle here is 54 and 9.3. So, okay, so let's just continue. So, let me go to the next one. Guys, this is a board work will be available on my test shop. So, guys, just get access to it and practice more. You can just click this refresh to solve as many problems as possible to evaluate your ability. Okay, similar shapes. Okay, if one shape is an enlargement of the other, then the shape are said to be similar to each other. Don't forget that in similarity, the angle remains the same. I said, okay, but the dimension could vary, okay? So the angle in the two similar shapes are the same size and the length of their corresponding sides are the same ratio. So the same ratio does not mean that they have the same dimension, okay? So a similar shape can be a reflection or a rotation of the original shape, and that's what makes this triangle similar. So angles corresponding and the ratio of the sides also are the same. That is the ratio of p um PQ and AB. We give it, let's assume that the ratio of PQ to AB is 2. Definitely the other ratio also should be 2. But however, the angles remain the same. If this angle here is 30, this will be 30. If the angle here is 60, then this will be 60, and so on and so forth, guys. We need to be very fast. So which of the following shapes are similar? Okay, just like the other time we have diagram, but this time around them you have this. So any two squares, yeah, so are similar. Any two cylinders, so that's, let me just go back and confirm that for you. So all these are similar actually. Any two square, any two cylinder, this board work, guys, and just access it via my test shop and take it easy. This video you can pause also to have a good understanding. Okay, so guys, I can vary the dimension here, then that means that I'll be able to change my scale factor. So if I should let me bring this thing up now, so you see the scale factor will change accordingly. If I increase the scale factor, then the stuff changes. So this board work, you can just go ahead and access it. Okay, also here I have some activity to complete that has to do with this, so I'm going to teach you what is going on here. But now the only thing is that scale factor, to find the scale factor, you just DE over AB. You look at this now, this is DE divided by AB, so that is 10 over 10. So the scale factor here is 1. So I'm going to explain better. So that's 10 over 10 each, so the scale factor here is 1. Okay, so we are going to do more work on that. So scale factor. Okay, so scale factor of an enlargement is found by the ratio between two corresponding lengths. Now, guys, in transformation, generally, let me quickly call your attention to. Okay, I need to activate my light shot. Let me quickly do that, guys. Sorry about that. I need to activate my light shot so that I can make some notes. So light shot. Okay, let's continue with that now. Okay, from current. Okay, so I need to quickly make some notes here. Now don't forget, in transformation, guys, you can also access the video via YouTube. In transformation, scale factor generally is the image dimension divided by object dimension. So by the time we start try to complete some tasks, there you understand this better. So I would like to go with this better, much more than, but you understand already. The scale factor of an enlargement is found by the ratio between the two corresponding lengths. So the corresponding length such that the length of the image divided by the length of the corresponding length of the object. So you should be able to identify which one is mapped to the other. So and that's what we have there. So guys, we're going to complete that one. So the following rectangulars are similar. What is faithful? So this one says that the scale factor of the enlargement. So if it is enlargement, meaning that this one is mapped to this. So this one is enlargement of this. So if you want to go for that now, is this here is an enlargement of this. So this is the image and this is the object. So that will give you 9/3. So you can reduce it. Sorry, 9/6. I'm in hurry. Oh my God, like this. I'm sorry, guys. So I reduce it. Then that will be 3/2. So that 1.5 should be the scale factor there. So that's what they have there. So guys, I will not be careful to complete the following tasks here. The following shape are similar. Yes. Angle A will be, because I told you that in similarity that the angle remain the same. So angle A will be 37, then angle B will be 53. Guys, don't forget. So the size, the angles will be the same in similarity. So and we go to complete some facts here. Let me just be fast because we have a lot of work to complete. So using similarity and congruency, I will just work on one here, then I will start my task. Now complete the table for the dimension. Now to complete the table for the dimension, the model, what model is given? Uh okay, so at 1/40th. What? 1/40th. That is 1/40. That's it. So 1/40 now. So that is 1/40th of the actual side is the model. Now let's go for example, if I want to solve this one now, the model width. Then go for real width. The real width is 2.2. Okay, and so you are going to divide 2.2 by 40 because or times 1/40. Okay, but I'm working in the model is in centimeter. So the first thing is to do 2.2 times 100 because 100 centimeter make a meter. So 100 times 2.2, and that gives 220. So then 220 now divided by 40 because you are doing 140, so that will be 5.5. So that if you want to do that now, so that's I want this is okay, 5.5. Okay, so that's how you are going to complete this task here. And if you want to find the real length, for example, you just multiply by 40. So for example, this is 6.4 for model length, so the real length will be 6.5 times 40. So 6.5 times 40, and that is 260. But this is in meter, not in centimeter, so you divide by 100. So and the answer there should be 2.6. So the answer here will be 2.6. Where is it? The model here is for the length. Oh, this is height. Sorry. Okay, I'm working with length. Okay, so for the height now, let me just quickly model height. If you look at the model height here is 5. So the real height here. So you just multiply this one by 40, then divide by 2. So let me just confirm that. So that to confirm, how do you get 2 here? So 5 times 40, 5 times 40 equals to 200. So the 200 divided by 2 to convert to meter. That's how you have to. So guys, this board work, guys, just try and download via my test shop and complete the task accordingly. So let's start with the main task for the day now. So this assessment task question on congruency and similarity. So I'm going to complete all these tasks, guys. So let's get started with the first question. So I can use my light shot now. So the first question here now says the first question says that list 2 minimum conditions that triangles need to satisfy to be congruent. So just 2 minimum conditions, but I can list as many as possible. So what are the conditions before you can satisfy the congruency? Don't forget that when I started, I missed out. I couldn't see that right angle triangle. So you need 3 parameters from side and angles. So you have to make up 3 parameters. So the first one, side. So we can have side will satisfy if the corresponding side are the same. Then we can also have side angle side, that is SAS, where this angle is included angle is in between the 2 given sides. Then we can also have as, guys, I'm sorry, just as, I mean AAS. So you can have as, so that is AAS, angle side. And also you can also have right angle, so RHS, right angle triangle side. Okay, so you can have that too, and that's all right. So 1 2 3 4. Can I have one more? Okay, so guys, that's cool one, but just take any 2 of these, guys. So that's the condition. So let's go to the next question. So decide whether the following pairs of triangles are congruent or not. If they are, what condition do they satisfy? Whoa, I think I like this question, guys. So let me quickly take my print screen. Let's take a look at it now. Now definitely these two are congruent. Why? So what condition? These two are congruent because I confirmed that these two are congruent. So why? The condition satisfied is SAS. If you look at the included angle here, so this is the included, it's in between the two given sides. So what about this one here? So this one is angle. Do you see now? Angle side. So does this one satisfy? Not congruent. Why is it not congruent? Because you can't just say angle side, because if it has to be angle side now, then there should be indication. Maybe there should be something like maybe one line here, one line here, or better say two line here, two line here, better say three lines there, three lines there. But since there is no indication of the side, so we don't know the relationship between the sides. So we only know the relationship in angle. So this angle equals to this angle and this angle, but the third information is not given. So this one is just angle, and but we need three parameters to confirm that it is congruent. So therefore this is not congruent. So not congruent, I'll put NC. Congruent, I'll put C. So this is NC, not congruent. So this one is C, congruent. Then this one now, this one here is congruent. Why is this congruent? Because this is SAS, it's SSS. And if you look at this now, this one correspond to this one here, this one here correspond to this one here, and finally this one here correspond to this one here. So the only one that is not congruent is these two second ones so far. Let's take a look at the next question. This one here, the last one, this last one I don't need to use my light short for this one. This is included angle here, sorry, this is right angle side, right RHS, so right angle triangle side. So this is the corresponding angle, and these are the sides. So this is congruent. So the question, and the only one that is not congruent is this one. So let's take a look at the next question now. So triangle, let me use my principle now. Triangle ABC is similar to triangle DEF. Okay. And we have to find parameter X. So what is this side here? And since these two are actually similar, so what are we to do now? So you can just, in similarity, this is what you do now. So the scale factor, I just like to use this scale factor because of in time we are going to solve a problem involving maybe area and volume, and or probably other 3D shapes, so that you understand it better. Now scale factor is such that, or better still, just take a given angle. If you like, for example, if you want to take angle A here now, this angle A here is correspond to this angle D here. Okay, so then the side too will correspond. So you can do something like 20/4, because this angle equals to this angle. So so you can say that side something like that. So this corresponds to this. So just take any two known value, go for any two given parameters. So this is known and this is known. Then you can now work with the two corresponding side also, the other one unknown. Let me use another color for that. Let's go for green here so that you understand what is. So the red one corresponds to each other, and the green one also corresponds to each other. So these two correspond to each other. And finally the let me take another color now. This blue one also corresponds to each other. So why against 2? So now, but let me find the two unknown. So I'll go for, let's go for X first, then we go for Y. So but this is the known, so you work with the known value first. So 20/4 equals to 30/x, equals to 30/x. So cross multiply. So if you cross multiply there, but I don't want to waste much time, let me just cut this 0, cut this 0 now. So if I have to cross multiply now, I have 2x equals to 4 times 3, 12. So 2x equals to 12. 2x equals to 12. So finally x equals to 6. So I'm through with x. So x equals to 6, guys. Am I correct? This is this cancel this. 2x equals to 12. 20 divided by 4 equals to 30 divided by x. So if you cross multiply, this can cancel this now. So 2x equals to 6. Okay. So let's go for y now. How do we for y? So go with corresponding side to also 20 divided by 4, because this length corresponds to this length. Okay, so 20 divided by 4. That is the known. So let's go for the corresponding and one unknown. Y, this is y divided by the corresponding blue 2. So when you cross multiply there, you have 40 against 4y. So 4y equals to 40. 4y equals to 40. So therefore y equals to 10. So guys, hope that is clear. So that is triangle. Okay, similarity in triangle. Okay, so let's go to the next question. So let's take a look at this blue one here. You have to find the missing value x, y, and x. So find the missing value y and x. Okay, so you apply the same rule. Go for two known. Okay, the two known here is I have 36 against 9 here. Okay, then go for the unknown now. So let me change the color now. Then I have 44 against x. So I will not write scale factor again. I will just, you know what is going on already. So the scale factor will be image. Let's say this one here is enlargement of this. This one here is enlargement of this. So this is the image, this is the object. So image dimension divided by object dimension. Image dimension divided by corresponding object dimension. So that is 36 divided by 9 will be equals to the same applicable here now is applicable there. So 44 divided by x. Okay guys, just go ahead and complete the task. Can I just go and do 36 divided by 9? I think I can have something there. 36 divided by 9 is 4. So that is better. I think I like to work with that because I don't want to waste much time. So this one cut, this one cut. So 36 now, that is 4 here. So if I cross multiply now, I have 4x equals to 44. So therefore x will be what? So 4x equals to 44. Then x is 11. So x equals to 11. Guys, hope that is clear. Okay, so then for y, and they asked me to find corresponding value of y. I don't have y here, guys. Okay, maybe that's question below. Because I think that question is not. This is sorry, guys. So this question here is for this up there. So these are sorry about that, guys. I like to play too much. Why am I playing like KS1 baby? So okay, so this question is for this, guys. Okay, so this x and y is for this green one. Okay, guys, I just like those KS1 kid guys. I don't know if just try to keep their company, guys. Life is very easy, as in I just love those guys. Okay, now this one here, I'm to find the unknown variable x and y, and the same thing is applicable here. So look at this similarity here now. Don't let me go with green. Let me go with something that will work better on this red color. So let me just, I want to trace out something now. I want to look at this this triangle here, this red triangle, this small triangle. So this one is not this is what we call similar triangle. Okay, so this small triangle up here, then the entire triangle down. But let's go with this small triangle. Now if you want to work with this one, the dimension we are going to use now, what are the known dimensions? Do you have any two given known dimension? So if you look at this one here now, I have 48 here. So you can do 48 against x here. Okay, then you can now work with these two are known already. This one here, these two, for example, this length here is 5. From here, this red one, this length here is 5. Then the entire length, let me use blue for that. Green, let me use green. So I'm talking about the triangle now, the entire triangle. So let me use green now to indicate the entire length. Now from up here, you cover 5 already. Then from down here, 15. So 5 plus 15, that is what? 20. So the entire length of the triangle is 20 here. So this small red one is 5. The entire one is 20. So that's what I'm going to work with now. So you can now go ahead. The small over big or better still big small. I wouldn't know the way you want to put it. But let's say that this small triangle is enlargement of the big one. Sorry, the big one is enlargement of the small one, or the small one is reduction of the big one. So if you want to talk about enlargement now, then I will go with enlargement. Enlargement dimension is 20. Corresponding dimension is 5. Okay. Do you understand? The same side, I'm working on the same side. So 20 against 5, the same side here. Not 20 against 10 here. So 20 against the same dimension here. Okay. So equals to So now this one here is 10, but if you want to use the entire dimension here, the entire dimension here too will be 10 plus y, but this small one here is 10. This one is 10. This one here is 10 plus y. This one here is 10 plus y. Then similarly, I have 48 and x here too. 48 and x. So that's all. So guys, I think I would like to go with x first. So I can do this against this and this. So let's go with x against 48. But it's the big over small, so that will be 48 against x now. 48 against x. So I don't want to waste much time here. Let me just cut here. 5 here 1, 5 here 4. So you have 4 times x. So meaning that my answer here will be 4x equals to 48. 4x equals to 48. So x equals to 12. So x equals to 12. So this one, x equals to 12. So let's do the same thing for y. Let's do the same thing for y. Now for y now, the best thing for me is that I don't need to work with this y. I'll work with this big dimension y now. So I can do 20 and 5 also here also. Or better still, I can work with any of these ones. Since I have x too, I can work with x here too. So guys, for this one here, I have 10 plus y. Because I want to, you have this one now. This is 10. This is 10 plus y. So the entire dimension here. So 10 plus y. 10 plus y divided by the small, divided by 10, because the entire dimension divided by the small one, the small triangle, the red triangle. Okay, this is not a triangle, guys. This one is not a triangle. So divide by 10. So you are dealing with the triangles. Okay, equals to, that is the entire dimension, 10 plus y divided by the small, divided by 10. Okay, so equals to, you can take any known now. If you like, I can still work with this 20 and I can use this 20 and 5 as reference. So let's just continue with that. 20 divided by 5. So I don't want to waste much time again. Here 1, here 4. So cross multiply. So this is 40. Okay, so that means y plus 10 equals to 40. Y plus 10 equals to 40. So from there, what is y? Y will be 40 minus 10, and that is 30. Guys, hope that is clear. This is video you can pause and you can go through again, and that's a good one. So next question. So this question says that the two rectangles A and B are mathematically similar. The length in B are twice the length in A. So length in B are twice the length in A. So now let's do something now. Let the length in A be x. So if this x and this corresponding one, this will be 2x. So that's the implication. And so on and so forth. I don't need to work with any other dimension. If you like, you can label this one x and this one 2x. If you like, you can label this one x and this 2x. Just take any one you like. Okay, so that's that. So the area of the area of A, this one, the area of A, this area now, area of A, this area of A here is 14. So the area of B is unknown. Area of B is unknown. Let me just write it area of A, guys. Then area of B, let me write it as AB. Is unknown. So we have to find the area of B. Okay, guys, before you can do this, I need to quickly call your attention to something. Scale factor. Scale factor. Let's find the scale factor first. Scale factor equals to image dimension divided by object dimension. So let's say this one is the enlargement of this. So this is the image. So the image dimension now, that is 2x divided by the object dimension, which is, that is x. So the scale factor of this information is 2. The scale factor is 2. Okay, so let's keep that one now. Now in similarity, guys, you may need to go to YouTube or via my test shop. I made a video already on similarity of solid shape, where you use area and volume. So please go ahead and check. Immediately after the class, I'll take you to, I'll show you where to download that. So now, if you have area, we don't deal with scale factor, we deal with scale factor square. If it is volume, that will be scale factor raised to power 3. So since it is area now, so scale factor square equals to, now we are looking for B and it's the enlargement. So area of the enlarged one, this one, the area of B, and the area of B is the unknown. So let's call it, that's AB, divided by the area of A. So the area of A is given to be 14. Okay, so I can complete the task now. So Guys, sorry about, I need to complete it here. Okay, so now scale factor is 2. So let me, since I'm looking for AB, let me write AB first. Or let me just extend this one. Let me extend it, don't worry. I can extend this. Okay, so let me just end it here in this box here. So this is continuation now. Now, since I'm looking for area of B, so I'm going to use area of B as subject of formula. So that's why I want to write it on the left hand side. So area of B equals to scale factor square times 14. So scale factor is 2. So 2 square is 4. So 4 times 14. So you can go ahead and use your calculator to complete that. So 4 times 14, and that is 56. So that, therefore, the area of B is 56 centimeter square. Guys, hope that is clear. Guys, in part 2 of this video, can I say part 1? I actually made a video on similarity, just similarity generally, not triangle or something like that. Not similarity and congruency, similarity generally of solid and plane shapes. So try to explain that better, then you can download the video or get the resource via test. So I'm through, guys. Let's go to the next question. Okay, this one says that two cylinders A and B are mathematically similar, and the height of B is twice the corresponding height of A. The volume of A is 13, and find the volume of B. Okay, guys, don't forget you can just type this URL link or this address in your URL and access please just you see similarity. Okay, then you can get a better understanding for 3D shapes. Okay, now guys, I have this here now. Two cylinder A and B are mathematically similar. The height of B is twice the corresponding height of A. So let's go for A. This time around, let me work with Y. Let's say that the height of Y here, the height, this is height, okay. So let's say this height here is Y, and B is enlargement of A. So by implication, so that will be 2y. So that height there will be 2y. So since B is the enlargement of A, what is my scale factor? Scale factor is image dimension divided by corresponding object dimension. Don't forget the word correspond is the corresponding object dimension. You can't do dimension of this one divided by the radius. So it must be height to height. So that's 2y divided by y, and that is 2. So the scale factor is 2. So guys, but when you are dealing with volume, scale factor cube raised to power 3 equals to the volume, the dimension of the image divided by the dimension of the object. If it is area, you use scale factor square equals to the area, the image area, dimension of the image area divided by the dimension of the object area. So don't forget, and that is scale factor square. But for volume it is cube. So now let's go ahead, and I have this one to be 2 already. So I'm looking for B, so I'm looking for VI. So volume of B divided by volume of A, and volume of A is given to be 13, equals to scale factor raised to power 3. Scale factor is 2, so 2 raised to power 3. So therefore volume of B will now be 2 raised to power 3, and 2 raised to power 3 is 8. So that is 8 times 13. So guys, what is 8 times 13? So 13 times 8, and that is 104. So guys, that is 104 cm. Okay. Guys, hope you enjoy this tutorial session, a very lovely one, guys. So let me quickly show you something, guys. Let me just take you through the this now. So guys, don't forget you can type this URL, this address better still, your URL, just type test.com teaching resources, guys, and you go for similarity to have better understanding on how to find the in 3D shape, application in 3D shape. Okay, so you can access as many resources as possible. Then also you can also download the video via my YouTube. Please, guys, don't forget to click subscribe. Just click subscribe to my, and also here you can also review and these resources. If you find it very useful, please just click and review, and do have a great day ahead, guys. At this point now, I want to say happy day ahead, guys. Love you guys. Bye bye. Bye guys. Bye guys.